My name is Taylor, if you guys forgot. And Steph is also joining in the office to help with all the technical difficulty stuff. So we're going to continue on with our forest ecosystems lesson this week. And as mentioned, next week, we're going to be talking about the whale migration. Woo! Okay, Steph. So to start things off here, I got a little question for you. Do you know the difference, Stefania, between a coniferous and a deciduous tree?
Yeah, so deciduous, those are the ones that drop their leaves.
Yeah.
And they fall. And a coniferous is like a Christmas tree, like an evergreen tree.
Ooh, she knows something about forestry. So last week, guys, we learned about the 4 most common species that you can find here in the Pacific Northwest. And all of them were called coniferous trees. So those are your evergreen trees. And if you look at their needles, right? So all of the leaves were in their needle form. So they still do the same thing as normal big leaves, that they produce energy for the tree. They produce sugars for it to eat through photosynthesis. But then our deciduous trees are going to be those ones that are called broadleaf. That's another term to use. So those are those typical looking leaves if you were to draw one. But you can call them broadleaf trees. So sometimes in a forest stand, so the forest ecosystem itself, you'll have trees that are only evergreens. So if they're only evergreens, if they're all the same, we call those uniform forest stands. But if you were to have all broadleaf, kind of the same, a whole broadleaf forest, it's going to be a uniform stand. However, at times you have mixed forest stands. So if you look outside, Steph, can you see some coniferous trees and some deciduous trees outside that window? What do you see?
Yeah, so I'm looking at like the botanical gardens right now, and I see, yeah, both kinds of trees, mostly evergreens.
But mostly evergreens. So this is a really key thing. So today, guys, we are going to talk about how forests kind of come to be and why they might be all uniform trees, or maybe they're going to be mixed forest stands. And it all has to deal with how long that forest has been around. So we're going to talk about something called disturbances. We're going to get into something called succession. And then we're going to look at some really cool tree cookies that we chainsawed yesterday to get for you guys. And we're going to learn about how trees actually grow by looking at their annual rings. Sounds good? Yeah, sounds good. Okay, so let's jump into what a disturbance is. A disturbance is going to be anything that kind of upsets a forest stand. So whether it changes it completely, those are going to be our kind of stand initiating disturbances. So they're really, really big. So like I said, there can be 2 types of disturbances. So I'm going to split this screen really quick here. So guys, when we're looking and talking about forest disturbances, there's a bunch of different kinds that we can talk about. So using this little chart here, we have biotic disturbances. So biotic, what do we think that means? Bio means living things. So it's going to be disturbances that are living. So things like insects. Have we all heard about the mountain pine beetle? This beetle up north has wiped away some of our forests. It totally disturbed it so that it's a total stand initiating disturbance. So there's no trees left because he ate them all the pines. Then there's different pathogens and funguses. So different things that go in and will kill a tree, they'll decay it, they'll rot it out. We also have things like cow grazing. So if cows are eating too much, they can totally clear out a forest as well, especially if things are really small and trying to grow, then animals can eat them totally out and there'll be no forest to grow. But then we also have disturbances that are called abiotic disturbances. So these are kind of more those climatic disturbances. So fire and wind and landslides and floods and droughts. So again, these can come at all different frequencies, different intensities. But then guys, we also have our human disturbances. That's us. We like to disturb the forest sometimes. And these are things going to be along the lines of logging, whether it's clear cutting or patch cutting, we're removing the forest. There's also pollution. If we have too much pollutants going on, we love to pollute. And that definitely can disturb a forest stand. And as well, we have houses and we need to put our houses somewhere, right? So that means we're clearing out the forest to put our homes up. So all of these different disturbances kind of make up a forest stand, and they kind of control how this is going to grow. So we're going to get into how a forest grows now. We're going to talk about what happens after a disturbance. All right, so let's say we have a fire come through and rip down all the forests. So there's no live trees standing anymore. This means we have really bare soils because all of the nutrients that were in that soil also got burnt out. So succession. So it's kind of the healing process after a disturbance. So it's what happens or how trees grow in after some type of disturbance comes in. So we have, it's kind of stages. It all works in stages. So the first tree that comes in are called our pioneer species. And remember last time when we talked about how trees will grow in certain locations based on their certain needs, right? So with what were those again? Steph, do you remember? There was 3. Testing.
Water.
Yeah, water.
And soil type.
Soil type. And the climate.
Oh, yeah.
Yeah, you got it. So, right,
yeah.
you got it. So again, back to those deciduous and coniferous trees. These trees have different needs, and it's going to mean that they come in at different times after a disturbance. The first trees that come in here specifically, have you guys ever seen an old logging road? If you're like walking in the forest, or if you look and you kind of see a band of alders growing, so that's those first pioneer species. Alders are able to come in because they love the sun. The sun is, they're like sun babies. So they can't handle shade. And they're also really cool because they're nitrogen fixating plants. So they actually take nitrogen from the atmosphere and they can put them back in the soil. So it's making the soil more full of nutrients for other trees to come into. And as these alders grow, they're creating a layer, a canopy. And what happens underneath the canopy? Can sun go through a canopy? Hey, Steph? Definitely not, right? So it's creating a shady environment underneath. And our coniferous trees love the shade. So the trees that we really like, the trees that we value, that a lot of animals value, think of the cedar. Remember last time we talked about how bears like to hibernate in those rotting inside of cedar? So the alders come in first. And they can make the soils more nutrient packed and make it more shady so that those more like trees that can last longer, those trees that have really long lifespans can then start coming up. So that's pretty cool, hey? Huh? Now, Steph's out of it. Now we gotta talk about these different trees. So we're gonna talk about alders. So these large trees that come in first because they love the sun. They make our soil so lovely for everything else. And then we have our coniferous trees that are a lot slower to grow. Alders are considered a mature tree at 50 years old. That's not very old. When you compare it to a cedar that's mature at like 300 years old, those are crazy. So alders, although they can come in first, they only live for about 50 years and then their forest stand dies off. So what I have here is a giant alder cookie that I cut.
Whoa.
Look how big it is.
Whoa.
All right, I want you guys to guess how old do you think this alder is? If 50 is mature, how old do you think this is? It's pretty big. Steph, what do you got? Anything? What's your guess?
50 is, like, that's a pretty big tree.
This is a pretty big tree.
Close to 50, maybe 25, I don't know.
Ooh, that's a good guess. Steph guessed 25 and it is. It's actually 23 years old. And again, guys, we can know this due to a little thing called our annual growth rings. So you guys can see every single one of these rings, correct? Oh, yeah. And if we count every single ring, it's 23. So that's how you can tell how old a tree is based on its rings. We'll talk a little bit about the science behind the rings, but I want you guys to see how big some of these rings are, hey? This is big, it's almost as fat as my finger. That means that tree was growing extremely fast. Look how big it got in just 1 year. From 1 year to 2, it was already about this size. And every year it added on. So it's a pretty large tree for 23 years old, hey? Crazy. So this tree must have been in the light because it loves the sun, so it was able to grow really big, really fast. It must have been adding a lot of nutrients to the soil, so maybe it was in a wetter spot because they love moist soils as well. So this tree did really good. It was able to grow, and it probably allowed all these other tree species to come up growing underneath it. So our next tree cookie we have here is also an alder, except it's way smaller. I can't hold both because they're too big. Here we go. Boom. So we said this one was 23 years old. All right, let's take a closer look at this guy. Same tree species, so our deciduous alder tree. Let's have a look right up close. Let's look at their growth rings on that one. You can get it even closer, focus. Ooh, they're way smaller, correct? If I put my finger back in there, ooh, no, oh, it's gonna focus. Yeah, no ring is as wide as my finger like that other alder. So that means, but we're gonna, how old do we think this one is? Steph, how many rings do you think you saw there?
Oh, I didn't count.
She didn't count.
It might be like the same.
It was. This one's 21 years old. So let's take a closer look again. If this one's 23 and this one's 21, there must have been something going on within the forest that didn't allow this tree to grow as big as this one within the kind of the same time period, correct? You can see on these rings, they're way smaller. So the site that this tree was in was not as ideal compared to this bigger tree. So maybe some factors you can think about is maybe this tree was being shaded out by another alder. So if another alder is growing next to a tree and it's taking all of the sun and this one's now in the shade, alders don't like shade. So they're gonna add only a little bit of growth to that year. Or maybe it was in a really dry spot and alders don't like dryness. So again, maybe it didn't grow. So the conditions have to be super ideal, but it's pretty cool to compare that two trees pretty much the same age can look so different based on a different site. So we're gonna bring in our last tree cookie here. Ooh. So this is a different species of tree. This is one of the most common tree species. This is our coastal western hemlock. Woo! And if we zoom all the way up, whoa, its tree rings are super, super tiny. Steph, how old do you think this tree is?
Like really old.
This little tree, so it's pretty much the same thickness almost, or same, yeah, diameter as this 25-year-old tree. This tree is, what I could count by all the rings, is 87 years old. Whoa! But just think, guys, a hemlock isn't mature until it's about like 200 years old. And then it'll start kind of declining in its lifetime. So it still has so much more to grow. So it's going to get huge, 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 huge. And thanks to these alders, after our disturbance, it was able to grow underneath that shady canopy and grow up. And as the alders died off, it was able to grow even more. And it'll take over to be kind of what our forest outside this window looks like. So it's mostly coniferous, so mostly evergreen species, because it's an old forest. All of the young alders that came in first after a disturbance have died off. And now we have this really rich forest made up of really awesome species of hemlock and cedar, those ones that we really like to have and animals really like to have and our soils really like to have too, right? Because once they die, they put so much nutrients back into the soils. Pretty cool stuff. Do you have any questions yet? Can people still write in questions or not so much? Hey, I want someone in the comments question. I want someone to write the 4 species we went over. The first person that can write in those 4 species and get them correct, I don't know what I'm gonna do.
Which 4 species?
So on Tuesday, remember on Tuesday, we talked about 4 evergreen tree species, the most common ones. So someone write them in. I don't know what I'm gonna do. Maybe I'll do a dance. Maybe I'll make you something for next time. Maybe I'll give you a big shout out. Anyone? Anyone at all?
There's messages coming.
Oh my God, there's so many chats.
What's one question? Why is alder yellow?
The inside. So when it's first cut, which is kind of cool. So yesterday we took out our chainsaw and we cut. So this was the exterior part. So a few months ago, this side was cut and it's been exposed for a while. But our fresh side is still quite white, right? So it's kind of, it changes as time goes on. So as it's exposed to air for longer periods of time, it's gonna turn this yellowing color. Whereas if it's fresh cut, it's still that white inside. So maybe we should talk about how tree rings grow, hey? The kind of science behind it, because it's pretty cool stuff. So if we're looking at this tree ring, yeah, focus up. We have our layer of bark on the end, and right underneath the layer of bark is something called a cambion. So this vascular cambion is where new cells are added every single year. So the cells or the rings right in the middle are really, really old. So those are the first rings that grow. And every year it adds a new one to the outside. So these are the newer rings added, so the past times. And a really cool thing about Actually, we'll leave that one for Mark's video. We have a cool little video to add at the end. But cool thing about tree rings is that you can kind of see what was happening in the climate each year. So if there was a drought year and the trees didn't grow really or didn't have the right conditions, the ring will be really small because it didn't have enough nutrients to grow or enough water to grow that year. Whereas if the climate was really ideal, the rings might be a lot fatter. And from this alder, you can see that most trees, their initial growth, so when they're young, just like you guys, are going to be growing all the time and they grow really fast. But as they get older, they slow down in their growth and they don't get as big. So the rings on the outside are known as sap wood. So this is the living cell wood still. And this is how a tree passes all of its water. So it grabs it from its roots and transfers it up through the trunk to the canopy. So all of the water and nutrients are going to be passed through these sapwood. And really young trees, so normally you can tell sapwood by different colorations, but because this tree is so young, all of this could still be sapwood. But as a tree gets older, just like we talked about last time, you need to think about that ratio between the trunk width and the height. So it needs to support a tree getting really tall. So the inside cells will start dying and that turns into heartwood. Shout out to all my heartwood people. It turns into heartwood and it's dead cells and it no longer transports water or nutrients for the tree. Instead, it has a different mission. It starts to be more structurally sound. So, and it also changes so that it's not prone to pathogens or insects. So it's a lot harder for insects to attack the inside of the tree, and it's a lot stronger so that it can support this tree getting super, super tall. So that's pretty sweet. And then the very center of the tree is called the pith. And that's, again, kind of like a soft tissue area of our tree that also can support the transfer of water and nutrients. So it's pretty cool stuff. Yes.
That center of the tree. What is that word again?
Pith. So P-I-T-H is a pith.
And you say it's softer?
It is. It's like a soft tissue. So if you ever core a tree, it was always the goal to try and put a tree core in. So if you put a core, you screw it all the way in the tree, it cuts into the center. And if you hit the pith, you were like the best tree core. But you can see it's a lot softer, which is kind of cool. All right, Steph, should we maybe watch a little video to sum up our lesson today? So we had a little fun down at Big Beach and we made a little video to see how it works when we splice it into our Zoom sessions. So we're gonna learn a little bit more about tree rings and growth and just how big they can get from our executive director, Mark. Yay, Mark.
Oh, hey Taylor, how's it going? Hello, old friend. Boy, it's great that in these times of social distancing, we can still take advantage of some of the amenities our community has to offer, like the beautiful Wild Pacific Trail, which starts right here at Big Beach in Ucluelet.
Hey Mark, what you leaning on there?
Oh, this old guy? This is a huge piece of a huge western red cedar. So this is one of the common tree species that we have here on the west coast. You're going to learn all about them in the classroom with Taylor. But one of the cool things that I like about this tree is it lets us look into its past.
Hey Mark, what are all these stripes in the tree here?
So each one of these stripes is what's called a ring, and each one of these rings corresponds to 1 year of growth. So you can see how many rings are on this tree. It's had a lot of years of growth.
Old growth, you say? How old, Mark?
Well, I'm no tree expert, but if I had to guess, I would say that this western red cedar was between 895 and 905 years old.
That's a really good guess. Hey Mark, is that a tree growing inside of another tree?
Well, it kind of looks like that, but not really. So one of the interesting things about western red cedars is when they do start to die, they usually die from the inside. So the inside of the tree starts rotting out. And when this tree was placed here as an educational interpretive aid, it was deemed necessary to sort of recreate the entire lifespan of the tree. So this insert is actually a different tree that is fitting inside the hole that began to rot as this tree, the bigger one, started to die.
Makes sense, Mark. All right, Mark, let's talk about this tree's life. What was happening during all of these ring growths? What do we got?
Boy, we pretty much have a good chunk of human history in here. If you go back 900 years and you came right here to this spot it would probably look more or less the same. But if you think of what was happening all around the world, there was all kinds of crazy stuff. That's one of my favorite things about big old trees like this. It's not just a big chunk of wood, it's a big chunk of history.
Hey, Mark, thanks so much for that lesson. We'll see you around town.
Hey Taylor, you got it. We'll see you around.
That's our executive director. We're gonna get him on film more because he's quite fun. But you guys can see within that 900-year-old cedar, its rings were so close together that you could barely even count between. Remember back to this alder that matures at only 50 years? Look how big its rings are. It grows fast, it shades the forest, and it allows other species to come in. So that successional stage of growth is a pretty cool thing to learn about. Yeah, that's kind of the lesson, Steph. How's it going over there? Anything we want to learn? Any questions we want to know more of?
I just scroll through.
Really old.
There was a question about how alders get to where they are.
Yeah, okay, so Alder's really cool. If you guys go to, you can even see Alders right now. So there's no leaves on the Alders quite yet, but you can see the old like seed packs on an alder dangling. So Alder's seeds are dispersed through wind. So they're really, really tiny and they're kind of like powdery almost. If you shake them, they kind of get all over you. And so birds can definitely help within the dispersal, but mostly they're dispersed through wind, which is really good here because our biggest disturbance is the wind. So they kind of can be blown into those super open sites and initiate their growth. I guess one thing we missed about talking was, yeah, here on the coast, the #1 disturbance is wind. So we don't have these big stand initiating disturbances come through. We have kind of one single tree will be blown down. And then that allows light to penetrate through to that forest canopy. And it allows a lot of mixed different species to come in. So that's why we kind of like have all these different structures and layers within a forest. Anything else? No.
Another question.
Yeah,
Someone
sure.
asked, what is the biggest tree?
The biggest tree? Like ever in the world?
They just say, what is the biggest tree? So
Big tree.
interpret it.
All right, whatever way I want. Well, I know that like the sequoias are massive. If you go down to California, they have the Sequoia National Park. It's huge trees. You can drive through them. But here on the coast, like where we are, I would say that the cedars get the largest for sure. Hemlocks have a little bit smaller of a age of maturity. So hemlocks kind of live to roughly like 600, where cedars can, yeah, they can go up to 900 like that big one if we let them grow. Unfortunately, a lot of the old growth forests here on the coast, there's no more, but we can let the ones that we've cut down and now our second stage grow until 900 years. But the cedars here definitely get the largest out of them all.
Someone asked what the oldest tree, is, and I guess you just sort of answered that.
Yeah, I would say like, yeah, like pushing 1,000 for a cedar, which is insane.
Yeah.
That's insane, you guys. Unreal.
What is the strongest tree?
The strongest tree. Like the hardest woods, right? So I'm gonna say like fir is really popular here, and we do have a little bit of Douglas fir if you go a little bit more inlet, so not just on the coast. But here, like the 4 that we kind of talked about, I would say that the cedar is like the most rot resistant. An old cedar, like if a cedar is like 200 years and falls to the ground, it is so rot resistant that it could last on the ground pretty intact. If you took a chainsaw to the center, the wood would still almost be like totally good to use after 200 years. It can lie on the ground for like just the same amount of time that it was standing. So it's super rot resistant and super beautiful wood, and it smells delicious.
And isn't there a wood wide web?
A
I think it's
wood?
kind of funny, like a world wide web, but a wood wide web. And I think I know the answer. I don't know if you're thinking of the same thing too.
No.
Fungi?
Oh.
Mycorrhizal network?
Yeah. Yeah. We should do. We'll do it. I think I'm thinking like after whales, we might have to do some fungus because I love the forest. But yeah, absolutely. I don't want to spill too much, but it is super amazing that underneath the connectivity between all tree species, it's pretty cool. Also, like I was thinking that this morning, aspen trees are sometimes can be all genetically identical, and they'll all be connected, which is unreal. And they get to be like kilometers and kilometers big of like the same being, which is so cool. So we should probably talk about that too in a future lesson because there's just too much to say.
How are holes made in trees that animals live in?
Ooh, okay. So we have our different types of bird species that are around. There's nest or cavity nesters. So these are going to be things like our northern flickers, all of our woodpeckers that are in the area. So these are the birds that go in and can dig out. So they kind of pick a tree, maybe like a standing snag. So one that's going to be a little bit softer inside because it's already starting to decay. And they'll go in and be able to make little holes. And they make them just big enough so that their bodies can fit into them. So they're really specific for every single bird species that does it. But then it also allows other birds to go in that maybe don't have a large beak like a woodpecker has, and can also find forage within their old holes. But then again, like we talked about with bears and hibernating, we have those big cedars, and you could see in Mark's video that the center of that old cedar only started to rot at like, maybe it was like 150 years of the rings. So those inner tree rings were able to rot out, and that's how cedars die. They rot from the inside out. So animals are able to kind of crawl underneath the root system and into those rotting in cedars to create areas for hibernation, which is pretty cool. Yeah, so again, like hardwoods and softwoods, this is considered a hardwood. So a lot of deciduous trees are considered hardwoods. And then a lot of coniferous trees are considered softwoods, and they have different like burning, like a different chemical makeup. So they burn at different temperatures. So it's always a kind of cool thing to know that whether you want it to burn really fast and hot, or if you want it to be like a slow burn that you can throw in for a long period of time, which is kind of cool. That different trees burn differently. Amazing. Yeah, we'll see you guys back here next Tuesday. Go out and enjoy the sun. It's kind of sunny. It was sunny. All right. Goodbye, everybody.